Hi, I'd like to do a demo of the GitPLM KiCad HTTP API connection. So this makes it much easier to connect GitPLM to KiCad so that we can serve up libraries created with CSV files and easily consume those from KiCad. So before we used a database type setup. It had multiple steps. It was fussy, very difficult to get working. This is much easier, so it's a big improvement. So to back up a little bit, GitPLM is a product lifecycle management system where we store the data in Git. This is mainly BOMs and part numbering data, and this is metadata around our designs. And since we store our designs in Git, we think it makes perfect sense to store the PLM metadata in Git as well. And this allows development to be distributed. Git also allows us to track changes, version things. If we're running Claude, we can see what changed and so on. So it works pretty well. So let's do a demo. I should first note that this is all documented in the README, and this goes over how to set things up and such. So let's first thing we should do is update GitPLM, and this goes out of GitHub and checks if there's a newer version, it pulls it down. So to start the HTTP library server, we just run GitPLM. Now, one other thing I'll note is we're actually in our parts folder. So this is a directory that has our database of parts, and symbols, and footprints. So we'll run GitPLM HTTP. This starts a library server. And then if we go to KiCad, we can hit A, and all of our GitPLM parts are in there. And each one of these parts corresponds to a line in a CSV file. So if we place one of these parts and then look at it, we'll notice the library link is actually the IPN. We really like this because the IPN is a unique number that positively identifies this part. It's not some fuzzy description. And it always gives us a concrete link between the library and the KiCad design. So let's say we wanted to add a part, and this is pretty easy to do with the GitPLM TUI. So again, in our parts library, we just run GitPLM. Let's go to our connector library, and let's search on terminal blocks. And let's say we want to add an 8-pin version of this. So again, we could open these CSV files in LibreOffice, but the GitPLM TUI is a little more reliable way to do it. There's some shortcuts, and there's just less chance we'll make mistakes. So let's copy this 12-pin version and make an 8-pin version. So we're going to change all the 12s to 8s. Okay, boom, we have an 8-pin version. We can look at it again to make sure no problems. And back to our schematic. If we hit A, and let's search on Phoenix, notice there is now a 8-pin version, and it has the right symbol and footprint already associated. We can lay that down, and we're ready to go. So this is very fast, and again, all we did was we created a new part in the CSV file, and then GitPLM, the HTTP server, automatically saw the CSV file change, reloaded the library, and the part was instantly available in KiCad. So this is the new HTTP. One other thing I'll show you is, so in our parts repo, there's a GitPLM file. This tells us where the database directory is. This is a directory that contains all the CSV files. And we can override a few things and set what fields we want to be visible. So a CSV file may have a bunch of fields, but we only want to show some of them on the in the schematic. So by default, we show the MPM, the manufacturer part number. But for capacitors, we want to show capacitance, voltage, material tolerance, and so on. For resistors, we want to show resistance, power tolerance, and different things. So each part category can have its own set of visible fields, and this gives us a lot of flexibility. So again, that's a GitPLM YAML file that you should have in the root of your parts repo, and this kind of tells GitPLM what to do with each part category. So another thing, if you look in database, these are the CSV files that actually have the data. So again, these are just text files. You can easily edit them and so on. So that's it. Let us know what you think, and if you have any questions, thanks.